Hello and welcome to Chapter 7. This is the chapter where it all really starts to pay off. We have been learning bits and pieces and doing little 2 lines, 3 lines, 4 lines of code to learn the basic building blocks of Python and learn some of the syntax and define lots of terms. But now we're actually going to start doing something. So if you look at what we've been doing so far, we're inside this little computer, and you type up, the Python says what next, and you give it its command, and it does something, and you do something else and does something, and you do this 3 or 4 times, unless you write a loop, and then it goes like 10, 20 times, and that's it. And then maybe we write a thing that reads something from our keyboard, gives us something back, and then we write something that prints something out, print a few things out, and so we've been pretty much using the keyboard, the screen, the CPU, and the memory. That's kind of where we've been living. And while it's important to talk to the keyboard and the screen, the real world is things like databases that live out here, files that live on our systems, and connecting to the network and reading data from the network. And so that's what we're starting to do right now, is we're starting to be able to work outside kind of our code and create things that are permanent. And so we're going to be talking, initially we're going to work on files. We'll later talk to databases and the network and other stuff, but for now we are talking about files. And so really kind of we're stepping out a little bit and reading things that are permanent and creating things that are permanent. The kinds of files that we're going to talk about mostly are text files, and you can think of these as a sequence of lines in a file that are easily read by Python. You've been making text files all along. Your hello.py, that file's a text file too. You're using a text editor to create that file. You put your Python commands in a file, you run those files, and that's what it is. And so a file can be thought of as a bunch of lines, 1, 2, 3, 4, 5, 6, 7, a blank line here. That's possible. And But the reality is that these are actually just lines, and we have a special character called the new line that we'll talk about in a second. So to read a file, you have to call the open function. And open returns what we call a file handle. Open doesn't actually read the file. Open makes it possible so that you can read the file. So the parameters to open are, it takes one parameter that's required, which is the name of the file, another parameter that's optional, whether or not to read it or write it. If we're reading the file, it doesn't harm it. You can read it over and over. If you write it, it actually, if there's already data in that file, it truncates it and writes something. And we're not going to really write files, we're mostly going to read them. And so open sort of, you pass it in a file, it gives you back this file handle, and then you have a variable in which you store it. I often call it fhand to be mnemonic. You'll see my code, I use fhand all the time to indicate that that is a file handle. And so if we were to run this in interactive mode, we'll open mbox.txt, and that is a function built into Python, and then it gives us back a handle. It does not give the data. And you can kind of see this when we print out the file handle using the print statement. It doesn't print the lines that are in the file. The lines that are in the file are sort of out there. There could be like 10 million lines for all we know, lines in the file. The handle's like a little opening outside of your program, and you can talk to the file by opening it, then you can read stuff, if you're writing the file, you can write stuff, and then you close the file to shut the handle down. But handle is a thing that allows you to get to the file. It is not the file itself, and it's not the data in the file. It's just a wrapper that kind of allows you. So this, if you print it out, it's like, that's the file we opened, we're reading it, and encoding has to do with the different kinds of character sets, which we talked about at the end of the last lecture, that Unicode character set, etc. UTF-8 is a great character set. It's probably the most typical character set that you will run into, although you can have different character sets of files, but most of them are UTF-8. So, of course, this is Python. If you make a mistake and there's a file that doesn't exist, we get a traceback, and it blows up. We'll show you in a second how to deal with that. Now, the new line character is an important part of file reading. And in files, in strings, we can put the new line character in by this \n character. And the \n is the character that indicates that we're supposed to go to another line. Go to a new line. Go to a new line. And so we have, what is this? Well, that's a \n. That's a \n. And so if we print it out, we print it this way, we see that the \n is in there. This is how we type it. We actually type \n to Python to indicate that we're supposed to put that there. But if we do a print statement, it actually interprets the \n, and so the \n causes kind of this movement to the beginning. Now the print actually, at the end of this, adds another \n. So the \n that we put in by putting it into the string is that one, and then print always puts a \n at the end. There's actually a way to override that \n behavior by putting something on the print statement, which we'll talk about later. Now, it's important to note that the \n is one character, right? And so even though this x\ny prints this, and then print adds another new line to go down to here, if you ask how many characters, what is the length of this? Well, it's only 3. That's because that's a character, the \n is a character, and the y is a character. So it's a 3-character string. So the \n is a character like all the rest of the characters, but it's only, we encode it by typing \n. It's called an escape, where the \ is the escape, \n is a way to say new line, because we can't see it. It's a way for us to encode in a string this non-printable character, this invisible character. The white space, it's part of white space. So as we're reading through the file, we can think of it as a sequence of lines, and we can read these a line at a time. We can also read them a character at a time if we want. And so, but it's more common to say read this line, read the next line, read the line after that, etc., etc., etc. But the way to best think about this, it doesn't really matter. You can think about it as lines, and we will in most of the programs that we write. But realize that the way when we see this, when we see it like this, it comes back to the beginning, it comes back to the beginning. There's a character in the file at each of these points to say go back to the beginning. It's like hitting the enter key on your computer, and that is a new line. So you have to think that in the file, in order for your text editor and Python and everybody to know where the lines end, you put new lines in the file, and that's another character. So, you know, this looks like an empty line. This line here looks like an empty line, but really it has a single character, and the character is a new line. And it turns out that in a bit we're going to need to keep track of the fact that every line is ended by a new line. So up next, I'm going to talk a little bit about how to read files in Python. So we're going to find that there's a number of different ways that we can read through the file, but the most common way that we're going to read through the file is to treat it as a sequence of lines, and we're going to use the determinant loop, the for loop, to do this. And so what happens here is we get back this handle that opens the file and gives us back the handle. That handle x file is the variable I named I just named it x file. That's not the data, but it is a sequence. It is that file handle represents to Python a sequence that we can potentially walk through and then get all the lines. And it's the simplest, most beautiful, elegant way to read all the lines in a file. We use the for loop, and we have an iteration variable. This is going to take, when we talk about the file, cheese is going to be the first line, then the second line, then the third line, then the fourth line. So it's like going through a string, but you're going through a file now, and you're getting it line by line. So that's each line. I just picked a variable named cheese so you didn't get confused. Later I'll call this line, but Python doesn't know anything special by naming that variable line. Okay, and so this is, it's the for and the in, and so for, I read this as for each line in the file x, the file handle x file. So run this loop one time for every line and then print it out. So it's actually really quite simple. Okay, other languages like C or C++ or other languages, they have to write while loops with end of file conditions and all kinds of things that make this very difficult. But this is one of the prettiest things that Python has. It's a very, very pretty thing. Okay, so let's talk about what we might do. And we're going kind of back to iterations now. What if we wanted to count the number of lines in a file? Well, this is a basic loop counting pattern. So we open the file, and then like in all these loops, we do something to sort of prime the loop to get it started, set a variable count to 0. And I'm going to use the variable line that's going to go through each of the lines in the file, for line in fhand, down the file. And it's going to run this loop once for each line in the file, and the variable line is going to change. But all I'm going to do is add count equals count plus 1. And so that's just like from counters, that's just how you detect. So every time we see a line, we're just going to add 1 to the counter. We're not printing the line. We're not even looking at its data at this point. And then when the line is done, however many times it has to go, out it comes, and we print out line count equals count. And so if we open inbox.txt, this is going to do all this work and then print this line out and say line count is 132,045. So this is a little 5-line program that shows you how to count the lines in a text file using Python. Again, simple and elegant and not too much syntax for you to have to learn. Now it's also possible to read the file as a series of characters all in one go. Read the whole file in. Now you got to be careful depending on the size of the file. This is going to lead to a string variable with a lot of data in it. Now if it's 100,000 characters, that's actually kind of a small thing. But if it was 10 million lines, that would probably not be good. You'd want to read it one line at a time and process each line and then do something. But mboxshort.txt is a small little file. So we open it and we get back a file handle object, and we call the read method, and that says go through and read all the text and give it back in one big blob, one big string, and I'll put it in imp. And so that's where you have a line, a new line, a line, a new line, a line, a new line. It's not really lines, it's just a sequence of characters with new lines in there to punctuate them. And now you can split that, later we'll see how to split that into separate lines if you want. Now I picked a file that was short, and so this imp variable now has a string in it, and I can use the len function, pass a string into the len function. It says, oh, 94,626 characters. That's kind of a small little file, and perfectly okay to read it all in one go. And so now I say just print the first 20 characters. That's beginning to up to but not including 20, and so it shows the first 20 characters of that little file is a from line, because this is a mailbox file. Now, let's say we're going to do a searching, and we did this loop where you're looking for something. And so we're going to search for lines that have a prefix of from. Okay, that's what we're going to do, and we're going to print those lines out. So there's lots of lines in this file. Line, 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 from. Line, 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 from. Right? On and on and on. And we only want to show these lines, the ones that match, right? That's what we want to do. And so we are going to write an open statement, and then we're going to loop through, and we're going to ask the question, if the line starts with from, print it. So sometimes it's going to skip, 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 and then it's going to run it, and then skip, 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 and it's going to run it, skip, 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 and then it's going to run it. Okay? So that's the basic idea, and then it'll finish when it's all said and done. And so this is like a criteria. This is like a search. We're looking for lines that match the string, that have the string from as their prefix. Now, when we look at the output of this, it's kind of weird. We see kind of these little blank lines that show up. Blank, 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 blank. What's going on here? What's going on? So let's take a quick look. The problem is new lines. Well, I mentioned that the file has new lines in them. And so when you do the for loop, it doesn't throw the new lines away. As you might expect, it would be kind of nice if it did, but it doesn't. It actually shows you when you read, it reads that first line up to and including the new line and gives you that back as the variable. So that is the first new line, so that means it's going to go down. And then the print statement actually adds another new line. So that's the second line of the file has a new line at the end of it, and the print statement adds another new line. So if we take a look at the code, there is a new line. Oops, come back. If we take a look at the code, this variable line has a new line in it. Oops, where am I at? I'm in the wrong slide. There we go. Yeah, this is the one I want to do. If we look at the code, there's a new line in here, and then the print adds another new line. So the print adds a separate new line. And that's how we get two new lines. The print statement's new line and the new line from the file. Here's how we fix it, and you're going to write this code a lot because when you're reading text files, you end up with a new line, and often you don't want the new line. But thankfully, as we saw in the previous chapter, there is a nice little function in Python for strings called strip that allows you to throw away white space. And to review, remember white space is anything that doesn't print. and this new line is not a non-printing character. So rstrip gets rid of it. So it's a way to get rid of white space. And rstrip does it from the right end. So it's the right end of the string. And so if we just are going to loop through all the lines in the file, we say line equals line rstrip, and then this variable no longer has the new line at the end of it. We have our little if statement, and if we print it, then this line, the data has no thing, and then the data has no new line in it, so the print only goes down one. And so now we have single spaced output. And so you're going to be doing that a lot. It's really common to read through a file and then just strip the new line or any trailing space off the end of that. Now, there's a couple of ways to do a loop like this, and let's just think of this as we're looking for a file with lots of different lines in it, and we want to ignore all the lines except some, say, good lines, and we want to do something with those good lines, or the lines we're looking for. Needle in a haystack. This is like searching for a needle in the haystack. So if you look at this code at a high level, we're going to loop through everything, and then we're sort of picking which lines are, and these are the good lines down here. Now often we have a bunch more code that we want to do, and we're not just printing them, but we're going to do a lot of code. So sometimes you actually structure the loop a little bit differently. And so the way to do it, and this is going to do the exact same thing, it's just a little different way of thinking about this loop. So the top part is the same, we're stripping it, and what we're doing here is everything's the same here except we add this not. If the line does not start with from, that's the translation of that. If the line does not start with from, continue. So basically we have a skipping pattern. So the lines we're not interested in, we skip. So we come down, we skip a lot of lines. And then we find a line that's good, and then we fall through. So this is the good code, and then we have all the other good code that we want to do to that line. We have that showing up down here. And so there's just two patterns, two ways to do the exact same thing. So another way to select the lines that we're interested in is to use the in operator. So we talked before about the in operator and how that works. So we're basically going to use the continue skipping method. So we're going to read all the lines, these first few lines. If uct.ac.za is not in the line, skip it. And so this is going to print out all the lines that have the string uct.ac.za in them. And so you see this is the output of the program, ... Sometimes you'll have programs that want to read different files. Often I give assignments where I say, show me how this program runs on the short file, and then show me again how it runs on the long file, just like this. And so the way we do that, to input the file name, instead of making the file name be a constant to the open call, we make the file name be a input. So we just run an input statement, which gives us a prompt, and then we type mbox.txt, and then that shows up in this variable f name. It's of course a string all the time, and we pass that into open, and then we open it, and then we do the count operation. So if we enter mbox.txt, it counts 1797 subject lines in mbox, and if we give it mbox short, it says there are 27 subject lines in mbox. And again, this is another one of those ifs, and it's just counting, but only counting lines that match a particular pattern. Okay, so now the user can also type bad file names, and we need to be able to deal with that as well. And so we're taking a small change to the code. The dangerous code is this line right here. This line right here is going to trace back if that file doesn't exist. So what do? Well, we're going to just expand that. The rest of this program is exactly the same. The only thing's different is we've got this line. We took out insurance on it, and we know that it might blow up, and so we have it in a try and except block. So here's how the code runs. So, the input runs, we type in a good file name, it comes in here. This works, and so it skips the except, and so it runs the code and prints out the count. So that's the good pattern. The bad pattern is here, where we type in a bad file name, it comes in the try except, this file name is nanabubu, and it's going to blow up, so this line blows up, so it jumps down into the except code, prints out, file cannot be opened, so it prints this out. Now this quit is really important, because if we don't put this quit in here, it's going to continue down here, and that's going to blow up here because file handle is not defined properly at this point. And so what we have is, we have this quit is a special function where it comes in and never returns. So this is a way to terminate the entire Python program silently with no traceback. Right? So we put in our own error message, so we look like we're professional, say, oh, could not open this file, and then we stop. If you don't, it's going to come down here and it's going to trace back right there. It's going to blow up. So the quit is useful when you want to stop executing because you've detected some kind of an error. So that's a quick zoom through opening and reading through files and doing some patterns. Most of the rest of the programs in this course are going to say open for rstrip, look for, and then do something interesting. That's going to be our loop that we're going to do over and over and over again. And now we see how this looping and if and iteration and variables are starting to come together, and you can actually sort of do a program that does something useful. But before we get to too many more programs, we got to switch a little bit, switch gears, and talk up next about data structures, and that is the shape of data and how we can use more intricate and complex variables to help solve our problems. Hello, and welcome to Chapter 8. We're going to talk about lists in this chapter. Up to now, we've been talking about algorithms. Algorithms are the concept in computer science of using the programming language to express the steps that you want the computer to go through to solve the problem. Read some data, convert it to a floating point number, check to see if it's greater than 40, do one thing if it's greater than 40, do another thing if it's not, then print out the result. Or open a file, read everything. If the first line starts with something, do something. If not, skip it, and then add all the things up. Those are steps. Those are a series of steps, and hopefully by now you're getting to the point where you have a good understanding of steps. But there's a whole other side of computer programming, and we call it data structures. And data structures is not the steps, but instead clever ways that you lay out